All right, let's continue. This is part 2 of limits at infinity and horizontal asymptotes. Example 4. Find the horizontal and vertical asymptotes of the graph of the function f of x equals the square root of x squared plus 1 all over 3x minus 1. Let's start with our horizontal asymptote. So we're going to approach infinity. So let's look at the limit of our function, square root of 2x squared plus 1 over 3x minus 5 as x approaches infinity. Now note here that our largest degree is in fact only x and not x squared, and that's because our term here, this 2x squared, is under the radical, meaning as far as its degree is half, right, of the x squared, so it's just x. So what we're going to do here is we're going to divide everything by that square root of x squared, or x. Okay, so we're going to rewrite it. The limit as x approaches infinity, and then we have, I'm going to show this kind of a longer way, just so we can make sense of it. We're going to have the square root of 2x squared plus 1 over the square root of x squared all over 3x minus 5 over the square root of x squared. And note that's mathematically acceptable because we're doing the same thing to both the numerator and the denominator. Now here's where it's going to get interesting. We are essentially going to distribute, right, this division to both terms in the numerator and both terms in the denominator. In the numerator, this will be rewritten as the square root of 2x squared over x squared plus 1 over x squared, and that square root just kind of moves on to the entire thing. And then in the denominator, we have 3x over the square root of x squared, which is x, minus 5 over the square root of x squared, which is x. And then after simplifying, this becomes the limit as x approaches infinity, the square root of 2 minus 1 over x squared over 3 minus 5 over x. Now, just as before, any term that is some constant over x to some power will go to 0. So this goes to 0, and this goes to 0. So this then becomes the square root of 2 over 3. And thus, we have a horizontal asymptote at y equals root 2 over 3. Now, in order to see if there's another horizontal asymptote, we have to approach from the other direction. So we're going to repeat this process, except we're going to approach negative infinity of our function. Now, mathematically speaking, all of the algebra is essentially the same, right? So what I'm going to do right now is just say ... it matches what's above. The only difference is going to come when we get to this step right here, from here to here. Because when we square root, if we are approaching negatives, we're going to say that that square root of the x squared is actually going to be negative x instead of positive x. So our expression here will become the limit as x approaches infinity. Once again, the square root of 2x squared over x squared under the radical plus 1 over x squared all under the radical over 3x over negative x minus 5 over negative x. And then after simplification, this becomes the limit as x approaches infinity, the square root of 2 plus 1 over x squared over, so I can write that a little neater, all over negative 3 plus 5 over x. And then every term that is a constant over some sort of power of x goes to 0. So then our answer comes out here, negative root 2 over 3. So we have a horizontal asymptote at y equals negative root 2 over 3. All right. Now, get this down because I'm going to erase it, and then we're going to look at our vertical asymptotes. Now, graphically, this root 2 over 3 and negative root 2 over 3, we can't see that here. So we'll notice here in the picture that we have a horizontal asymptote there and there, right? Same value, one's positive, one's negative. All right, now let's look at our vertical asymptotes. Now, we learned back in pre-calculus that the vertical asymptotes occur when we approach a value and it goes to infinity. In this case, we learned specifically that it is where we have domain issues. So this function, f of x, has an issue with the domain when this denominator is equal to 0. So let's focus there. So we notice here that 3x minus 5 equals 0 is going to create a problem, right? So we know then that 3x equals 5 creates a problem, or that x equals 5/3 creates a problem. So in terms of calculus, we'll say the limit as x approaches 5/3, let's do from the left, of our function, which is square root of 2x squared plus 1 over 3x minus 5, right? And then if we try to plug in 5/3 from the left, then the value in the denominator will become really, really close to 0. And the numerator is going to be some constant, right? So ultimately, we get this 2 times, 5/3 squared plus 1 divided by 3 times 5/3 minus 5. Now note, it's not actually allowed to plug this in because we will get divided by 0. So here's what we're going to say. So because we're coming at this from the left, we're going to note that the numerator is a constant and that the denominator is to the left of 5/3. So this is going to be a really, really small negative. And we're going to use this notation here. Parentheses with the minus is going to mean really small negative. Now, if I have a constant divided by a really small negative, we then see that it's going to come out really big negative, right? So if I have one object and I try to figure out how many super tiny things fit in it, it's going to be infinite. But because we're dividing by a negative, it's going to be negative. All right. Now, if I repeat that process, but from the other side, so 5/3 from the right, and we've got this function, 2x squared plus 1 over 3x minus 5, essentially the same thing happens. The numerator will be some constant, right? This constant specifically, and the denominator will come out a really small positive. And so that'll result in a really big negative. Now note this here is not an actual calculation, but more concept than anything. And you look at the graph and you see that is what happens. We approach that 5/3 from the left, and we go down here to negative infinity, and from the right we go to positive infinity. Therefore, we see that we have a vertical asymptote at x equals 5/3. All right, let's look at another example. Example 5. Find the limit of square root of x squared plus 1 minus x as x approaches infinity. Now, looking at this directly, it does not look like the others, right? In that it's not a rational function. So what we're going to do is we're going to kind of trick this into being one. So we're going to multiply it by a conjugate. But remember, we're going to treat this as over 1, and we're going to do the same thing to the denominator in order to keep this expression equivalent. So then this becomes the limit as x approaches infinity. And then remember, we multiply those radicals. It just becomes x squared plus 1. And then we have here x root x squared plus 1, and then negative root x squared plus 1. Those cancel. And then, of course, negative x times x is negative x squared. All over root x squared plus 1 plus x. Now, simplifying this, we get the limit as x approaches infinity. The x squareds here in the numerator are going to cancel. So we are left with 1 in the numerator over the square root of x squared plus 1 plus x. And now we're going to essentially do the same thing we did before. So divide everything by x. So 1 over x square root of x squared over x squared. Remember, when we put the x in the radical, it becomes x squared. 1 over x squared, x over x. All right, so then this gets rewritten as the limit as x approaches infinity of 1 over x over the square root of 1 plus 1 over x squared plus 1. And then once again, any term that is some constant over x to a power goes to 0, 0. So this gets rewritten as 0 over the square root of 1 plus 1. So 0 over 2, which is 0. So we have here, if someone were to ask, we have a horizontal asymptote at y equals 0. And we'll see that right here. All right, let's look at this one. Example 6. Find the limit of the arctangent of 1 over x minus 2 as x approaches 2 from the right. Okay, so mathematically speaking, this then becomes the limit of this inside function. So I'm going to rewrite this. Arctangent of the limit of 1 over x minus 2 as x approaches 2 from the right. And then this will be the arctangent of whatever this is. So in this case, this is 1 over 2 minus 2, but we're picking a number to the right of 2. So this is going to become 1 over a really small positive. Okay, so then this is the arctangent of 1 over really small positive. So this is essentially infinity. So the real question we're asking here is, what is the limit as x approaches infinity of arctangent? That's essentially what we're asking, right? All right, so if we look at the graph of arctangent, we can understand what's happening here. So let's take a look. So we look at the arctangent, we'll notice that as we approach infinity, we get stuck right here, right, at this pi over 2 value, right? This y equals pi over 2. Now that makes sense because tangent has asymptotes, right, at every pi over 2. So the arctangent then has a horizontal asymptote at pi over 2. So then we're going to say this is pi over 2. Looking at the graph, we can see that that is true. All right, last one. Find the limit of e to the 1 over x as x approaches 0 from the left. Okay, so mathematically, this gets treated as e to the limit of 1 over x as x approaches 0 from the left, which then gets treated as e to the 1 over really small negative, but a really small negative is mathematically 1 divided by a small negative is a really big negative. So now we need to think graphically about this e to the x. Now note, e to the x looks like this, and if we approach negative infinity, this goes towards 0. Okay, so that means this is 0. And when you look at the graph, you see that it does in fact approach 0. Oh, one more. The limit of sine of x as x approaches infinity. Now sine, if we look at the graph, we know it oscillates. So if we approach infinity, at no point will it reach a limit. So in this case, we're going to say d and e because sine of x oscillates. Because to have a limit means to approach a singular value. And that's that. All right, your turn to get some practice. Grab a book, see what you can do. Message me with any questions.